Okay, so today we're going to extend our knowledge on directly proportional relationships and connect it to inversely proportional relationships. So directly proportional relationships, I kept forgetting that directly word, means it's any line that goes through the origin. Any line that goes through the origin is directly proportional. And we have k, y equals something times x. And that k is really the ratio of y over x. Okay? The ratio of y over x. You can use algebra to identify that. If I had y equals kx, and I'm like, hey, what's k? Well, get k by itself. So this is k times x. To get rid of times x, you divide by x. That would cancel that out, and you get k equals y over x. Algebraic reasoning there. Well, notice that the inverse, we used inverse all the time for solving equations back in our algebra unit. The inverse of timesing by x would be what? Dividing by x. So the inverse equation looks like y equals k divided by x. Now let me just specify that again. Direct is k times x. Inverse, well, the inverse of times is to divide. Y equals k divided by x. So this is direct, and this is inverse. Okay? And I'm going to tell you that to identify inverse equations, if I were to get k by itself, I would have k equals x times y. You see that? That's using algebra to isolate k. So, here's what I need you to know. Directly proportional, the ratio is the same. I always check the ratio first. In inversely proportional, the product is going to always be the same, x, y. Now the graphs are interesting. I love inverse graphs. They're really interesting. Notice that if an inverse equation is k over x, well, anytime we put divide by 0 in our calculator will always tell us, nope, you can't. There's an error. So if you have a ratio, it can never be 0 on the denominator, right? So notice that the graph never hits that axis because it makes it an unreal number. So it will get really, really close to 0, but it will never hit 0. It will never go through that origin. Direct goes through the origin. Inverse totally avoids it because you can't divide by 0. You can't have 0 that way, okay? So one of your learning targets, perhaps you remember this from from the OPAs. I'm going to give you a graph, and you're going to say if it's directly proportional or inversely proportional. Inverse, weird word, weird graph, okay? Direct, directly through 0. So what's the first one? Why is it direct?
It goes through the center.
Because it goes through the center, the origin, that's what I'm looking for. What's this second one? Inverse. Inverse because it never touches the origin and it looks weird. What about this third one? Directly or inversely proportional? Notice that it's weird. It's never going through the origin again. Anytime it doesn't go through the origin, it's inversely proportional. Directly or inversely proportional? Directly because it goes through the origin. This is level 1 concept, right? Just being able to say what it is. What's this one? Direct. And why is it direct? Yeah, because it goes through the origin. What's this one? Inversely, because it avoids the origin. So this is inversely. And think about it. Direct through the origin, the inverse of through, inverse is like opposite. The opposite of going through the origin is totally avoiding the origin. That's what that means. Okay, so I'm doing a lot of comparing it to directly, and that's what today is. You have to apply both knowledge, both concepts. So you're going to be given tables again today, and you're going to have to tell me, is it directly, write directly, I always forget that. Is it directly proportional or inversely proportional? Direct ratio is always the same. Inverse, the product is always the same. And if you always start with ratio. And you say, hey, ratio y to x. We've been doing it pretty much this whole unit. And you say, well, what's the inverse of a ratio? Inverse is like that opposite operation, would be product. Okay, so I'm going to go ahead and start with this first one. So I have the ratio of 4 over 1, 8 over 2, 12 over 3. Are they all the same?
Yep.
Which is 4, 4, 4. So this is directly, and you'll have to specify that for me today. Directly, and my equation is y equals 4x. Maybe I should show you what the equations look like. Y equals k times x, and inverse is y equals k divided by x. Right? The inverse of timesing by x is dividing by x. And you need to know what the inverse is. This k is that ratio, wait for it to come up, of y over x. This k is the ratio of y times x. Okay, we're going to do this one. Check the ratio. Is 20 over 3 the same as 10 over 6? 20 divided by 3 is 6.6 repeating. 10 divided by, well, I know that's not going to be it. So no, it's not directly. So now I check the product. I check inversely. So 3 times 20, 60. 6 times 10, 60. 12 times 5, 60. So this is inversely proportional. This is that k. It's like the constant of variation, except it goes on the numerator. So it would be y equals 60 over x. Right? Think about, plug the x in. 60 over 3, 20. Plug the x in. 60 over 6, 10. Plug the x in. 60 over 12, 5. Okay? The next one, I want to check to see if this is directly proportional or inversely proportional. Direct is the constant ratio. So that's, if you're like, what the heck, how do I start this? The first thing I do is check the ratio. If that's not the same, the second thing I do is check the product, if you're ever confused. However, I always start with the ratio. 6 over 3, 8 over 4, 10 over 5. I already can tell it's the same. But I might as well just be consistent. 12 over 6, 14 over 7. 2, 2, 2, 2, 2. So this is directly, because the ratio is the same. And my equation is y equals whatever that common ratio was to x. Okay? I check ratio first. And sometimes you're going to be able to do it fast, and I already can tell that it's going to be inversely. But I always check my ratio first. 8 over 1, is that the same as 4 over 2? Nope, nope, nope. So now I check inverse. Inverse means the product is the same. 8 times 1 is 8. 4 times 2, 8. 8 times 1, 8. 2 and 4, 8. A half is 16 is 8. Hey, the products are all the same, so this is inversely proportional. And my equation for inversely is y equals whatever that common product was, and then you divide it by x instead of multiplying it. Okay? So the next one, I start with my ratio y over x. 25 over 2 is definitely not 10 over 5, right? So I can tell right away that it's not directly, so let me check inversely. 25 times 2 is 50. 10 times 5, 50. 50, 50, 50. Hey, this is inversely proportional. And I know that inversely proportional is y equals whatever that common product was, 50, divided by the x.